All right, we are back to using trig functions in cases where we are using angles of elevation and depression. So this is section 5 of chapter 8, angles of depression, angles of elevation. Think about what those two words mean, elevation and depression. And that'll kind of help you know what we're talking about. If you elevate something, what does that mean? Usually means you make it go up. So an angle of elevation is pretty much a situation where you are looking up. An angle of elevation is an angle formed by a horizontal line. Horizontal, what does that mean? Going across like this yellow line here, that's horizontal. And the line of sight, so you're looking to an object above the line that is horizontal. So it would look something like this. There's your horizontal. You're looking up. The angle that is created here is your angle of elevation. So if you're standing on the ground looking at a cat in the tree, the angle at which you are looking up is your angle of elevation. Okay, but the cat who is in the tree looking at you down on the ground would not be looking up. He is looking down. And therefore, we call that an angle of depression. To be depressed is to be down. Okay, it can apply to your mood, but it can apply to other things. An angle formed by a horizontal line and the line of sight to an object below the level of the horizontal. So again, it's like you're looking down. So here's your horizontal line. If you're looking down, the angle that is created there is your angle of depression. Okay, so know what those two words mean. What kind of situations would use an angle of depression and what kind of situations will use an angle of elevation. Okay, now we're going to be using our trig functions here to find these angles or to find distances involving these angles. So here's the situation using an angle of elevation. At the circus, a person is in the audience at ground level watching the high wire routine. Again, when you have a bunch of words like this, take it one chunk at a time and draw a picture. So here's a person in our audience. We'll just draw his head. He's at ground level. Okay, so that's our horizontal. He's watching a high wire routine. So what do you think? Is he going to be looking up or looking down? He's going to be looking up, so we're using an angle of elevation. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. So I'm going to draw that. Here's my platform. It's 25 feet off the ground from here to here. And we have this person standing on the platform. I know it's kind of a big-headed person, woman. And her height is 5 feet 6 inches. Well, we can't have mixed units here. We need to stay in feet because the other unit that we used here was feet. How many feet is 6 inches? It's half a foot. So we have 5.5 feet here. So I'm going to put 5.5. Don't put 5.6. Just because it's 6 inches doesn't mean it translates into a decimal, because this is tenths. Inches are twelfths, twelfth of a foot. You can't change twelfths into tenths by just using the same number. Can't do that. Okay, so now we have our picture drawn. How far is the audience member from the base of the platform? So we're trying to find this value right here. If the angle of elevation, here's my angle of elevation, from the audience member's line of sight to the top of the acrobat. So we have to know where he's looking. He's looking at the top of her head. And we know that that angle is 27 degrees. Okay, so there's my picture. I took it one phrase, one sentence, one chunk of information at a time and was able to draw a picture that will help me solve this problem. Now remember, we're trying to make right triangles here, so we know that this is my right angle. So I have an unknown side here. What would be the total length of this unknown side over here? Well, I have two parts. I have the 25-foot part and the 5.5-foot part. So together they're going to equal 30.5 feet. Okay, so I actually have a better picture drawn more professionally. So here's the audience member. We got our horizontal. Okay, we formed a right triangle because the acrobat's going to be straight up in the air. She's 5.5 feet tall. The platform is 25 feet. So together they're going to be 30.5 feet. So how are we going to set this up is the question. What trig function are we going to use? Well, in order to know that, we need to name these sides. Is this x the opposite, the adjacent, or the hypotenuse? Hopefully you said it's the adjacent, because it is. Okay, you can't see that white on white there. And what is this 30-foot side where the platform and the acrobat is? Is that going to be opposite, adjacent, or hypotenuse? Hopefully you said it's the opposite, because it is. So we have opposite and adjacent. Well, which trig function are we going to use? If you think about your SOHCAHTOA, opposite and adjacent is going to be tangent. Okay, so you're going to use tangent with opposite and adjacent, and we're going to plug that in. You should be writing this in your notebook. Okay, so tangent of how many degrees? Well, tangent of 27 degrees. Plug that in. Opposite and adjacent, what is your opposite side? It's this 30.5 feet that we combine here. And what is your adjacent side? It is x. So that's how we set this up right here. Now you can go on and convert this into a decimal if you like dealing with numbers instead of functions. Do you remember how did we get this number here? This 0.5095 from tangent of 27. I hope you remember. You just punch it in calculator. Just like it is. Tan 27, enter. Carry it to 4 decimal places. This part just stayed the same. Okay, this came straight from here. And then we made a fraction over our decimal so that we can cross multiply. When we cross multiply, we're going to multiply those two together to get 0.5090x, 0.5095x. 1 times 30.5 is 30.5. Now to solve for x, you have to divide both sides by this 0.5095. 0.5095. Those cancel. We get our x equals, if we divide these out, remember to punch this one in first. Divided by, bottom number second, hit equals. And again, this is an approximation because we've rounded. So it is approximately 59.9 what? What were our units? What were our units over here? Feet. So we should label our answer feet. Okay, so draw a picture. Then use all of the processes and techniques that we've been learning in the previous section using your sine, cosine, and tangent. Are you looking for an angle? Are you looking for a side? When do you use your second button? When do you not? All of that stuff you have to remember. So let's do another one using an angle of depression. From her treehouse, okay, so we're up in the air. She could be looking up, she could be looking down. So we have to read the context. Joan can look directly into her bedroom window. Okay, if it's a big enough tree to have a tree house, she's going to be looking down into her bedroom window. That is an angle of depression. The angle of depression from the tree house to the base of her house is, and for some reason, the 42 ended up over here on my PowerPoint, 42 degrees. The tree house is 10 meters from the base of the house. How far is the tree house from the base of the house? Again, you gotta have a picture here. Most people are going to need a picture. So here's the tree. Okay. She's looking, I didn't notice this before, directly. So that's straight across into her bedroom window. She must have a 2-story house. Okay, she's looking directly into her bedroom window. The angle of depression to the base of her house is 42 degrees. So we draw that line looking down to the base of her house and we put in 42 degrees. The tree is 10 meters from her house. Okay, so if this is 10 meters down here, then it's going to be 10 meters from where she is to her bedroom window. So we have parallel lines cut by transversal. How many degrees would this be? Alternate interior angles, that would be 42 degrees. Not that we need that information, just refreshing your memory of everything we've learned this year. So now we have our right triangle. So we go through our process. Which trig function are we going to use? If we are standing at this 42-degree angle, is this 10 the opposite, the adjacent, or the hypotenuse? It is the adjacent. Is this x the opposite, the adjacent, or the hypotenuse? I hope you said hypotenuse, because it is. It's the longest side. It's across from that right angle box. So what are we going to use? If we have adjacent and hypotenuse, which trig function is that? It's cosine. Right? So we set up our equation. Cosine, what's our degrees? 42. What's our definition? Adjacent over hypotenuse. What are the values of our adjacent angle or adjacent side and our hypotenuse? 10 and x. Okay, so again, we're going to set this up as a proportion. If we cross multiply here, we end up getting x times cosine of 42 equals 10. If I want x by itself, I got to divide by that cosine of 42 on both sides. Okay, just reviewing the algebra here. You should know this stuff. So x equals 10 divided by cosine of 42. How do I find this number? Okay, you can just punch in cosine of 42 in your calculator. You can punch the whole thing in just like this. Just remember that this means to divide. So you're going to do 10 divided by cosine 42, enter, and you get approximately 13.5. 13.5 what? Well, you need to look at your units. Already in the problem, it was meters, so we're doing meters this time. Okay, again, since we rounded, we use an approximation symbol. Let's do one more. Angle of depression. A wheelchair ramp is 3 meters long. Okay, a ramp goes up, so that should be at an angle. picture it. Picture a ramp. Okay, it's not going to be your horizontal distance. It's your slanted distance. And it inclines at 6 degrees. So here's how far up off the ground it is in degrees. Find the height. Okay, this distance from Y to W, that's how high the ramp ends up. That's my X value. To the nearest tenth of a centimeter. Okay, well, how are we going to set this up? If this is my given angle right here, this whole part, X is your opposite, 3 is your hypotenuse. So I have opposite over hypotenuse, which is sine. So a sine of my degrees, 6, equals my opposite value over my hypotenuse value. Okay. Hopefully you can figure this out now. So if I cross multiply, I get 3 times sine of 6 equals 1 times x, which is x. So I can multiply here. You can punch this in the calculator too. It's probably safe to make sure you put your parentheses in there. Okay, I'm giving you a minute to do it. How are you going to find sine of 6 degrees? Again, you're just going to punch in sine 6, enter. But you need 3 of those, so times 3. What'd you get? Here's it all set up all nice and neat. Okay. Now, why did they choose 31.4 if our answer, if you look here, 3 times 0.1 is going to be 0.3135 if I multiplied this out? Why didn't we pick A? What's going on? Well, if you notice, the units in our problem is meters. The units in our answers are centimeters. Okay. We need to move the decimal. Centi, like a cent, a penny is a cent. How many pennies does it take to make a dollar? 100. How many centimeters does it take to make a meter? 100. So if I have 0.3135 meters, I got to multiply it by 100, which means I'm just moving that decimal point over 2 spaces. That gives me 31.4 if I round centimeters. So units matter. Pay close attention to the details. That's always true in this class and helpful in all other classes as well. Okay, so know how to set up these problems using angle of depression, angle of elevation. You need to draw a picture, draw a picture, draw a picture. Make a right triangle in your picture and set it up using your trig functions. It all goes back to what we learned in the last section. So if you're still struggling, you need to watch the video several more times or come in for help. Okay, have a good